welcome to this video, and today we're talking about how to use list in Python. So list is basically an ordered sequence which consists of different elements. You can have different data types in these elements, basically integers, floats, tuples, strings, and you can even have lists within lists, and that's called a nested list. So we're going to get started, and you also know that a list is mutable, which means we can change the elements after we've created the list. Let's get started with creating our first list. You can see on the screen right here we have a sample list. So that's what a list looks like actually. You have elements separated by commas enclosed within square brackets, and you can see here we have different data types. We have integers, we have strings, we have none type, we have booleans. Okay, so now we're going to start with the first thing, which is how to access the contents of a list. So let's get started with that, and to use that we're going to use indexing to access characters. If you aren't familiar with indexing, we covered that in strings, and a lot of these concepts in this chapter are very similar to the concept in strings. They're pretty much the same concept except for the different data types. So if you understood those concepts, it'll be very easy for you to understand this chapter. So if you haven't studied indices yet, or you need a refresher on that, I'm going to give that to you. Quick brief of what indices are. So indices are basically a position in a sequence. So let's say we have a normal sequence and we have 10 people standing in a line, right? So if I want to go from left hand side to right hand side, let's say they're standing, they're right in front of me, I'm away from them, I'm seeing them from left to right, I'm counting them. So first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th from the left to right side. Now, let's say I want to move from right to left side. Well, I mean, it'll get confusing, right? So in Python, what we can do is first of all in programming, when you go from the left hand side to the right hand side, you start from 0. So basically the first position is the 0th index. So you go from 0 to 1 to 2 to 3 to n, right? And if you move from the right hand side to the left hand side, we start with -1. So we go -1, -2, -3, -n, right? That's how we can access characters in a sequence using indices. So let's get started with accessing characters. Let me say I want to print 4 from this list. So I go print sample, and we want 4. So basically that's the second element in this list, so the first index, and we get 4. Now I want to get none. I can either go from the left to right, or I can go from right to left, which might be easier. So I can use -2, and we get none, because that's the second index from the second position from the right, which is basically our -2 index. That's what we do. Okay, and the next thing is slicing. So slicing is a concept from strings, and I'm going to explain that again. Slicing basically means you get a range of elements within range of index values, and you use those to create a new list. So, and you can also have step values. So I'm going to explain that in a bit. Let's get started with how you create a range of indices. So to create a range of indices, let's say I want to get 3, 4, 5. So I'm going to start as the lower limit, which is 0. That's my first element, the lower limit. That's what I call it, lower limit. Lower limit is the index of the first element you want in the sliced list. Okay, then we're going to move to the upper limit, which is basically the last element you want. And the thing is with that, to use that in Python, you take the index of the last element you want and you add 1 when you move from the right hand side to the left hand side. You add 1. So basically you want to, if I have these numbers 3, 4, 5, I want to get these numbers, but I want, for the range I'm going to create from 0 to 3, because I want everything from here excluding this. So the upper limit is excluded, and the element at the upper limit index is excluded. So everything from the lower limit to the upper limit, excluding the upper limit, is in your sliced list. So let me say I want this 4. Whoops, let me print that. Sorry, 3. Yeah, 3, 4, 5. And now we get 3, 4, 5 because we got 0, 1, 2, and we exclude the third index because that's how this works. So that's how you slice this sample list. Okay, now let's introduce the step value. So step value is basically every nth value in that index range. So if your step value is n, every nth value in that index range will be added to the sliced list. So let's say I create an index range from 0 to 5, basically from 3 to 0, 1, 2, 3, 4, 5. Basically from 3 to none, all these elements would be in this sliced list. So 0 to 5 excluding true. Let's say I want to get every second element. So basically 3, 5, and none. So this is every second element. We get 3, 5, and none. So what I did here was we took 3, then skipped 4, then we go to 5, skipped high, and finally ended with none. And we got this sliced list. And I'm going to quickly show you how we can do that with the negative index. Also, we can use -2, and we will get the same result. Oops, sorry, -1, right? Because this is a bit tricky to understand here, but basically you want to use this position, exclude this position. So everything from here to here excluding this, and this is -1, so it's a bit tricky to explain this, so I'm not sure if you understand, but you go from here to here and you want to exclude this element right here. So you go from this index to this index basically, and the position of this index is -1 and this is 0. So if you're understanding this, the best way to actually understand how this works is by experimenting yourself, and you'll finally understand how to use a negative index in slicing. Okay, moving on, let's go to list mutability. It's a very simple example I'm going to use. Let's say we have, I want to change the value of 4 to 8. So say sample 1 is equal to 8. In this, we get 8 instead of 4. So what I did here was I accessed the value at the first index and changed that value to 8. That's what mutability is. You can change the value of elements after they've been created, after the sequence has been created, right? That's a pretty cool thing we can do. It becomes very useful for us later on when we write programs and all that stuff. So mutability is one thing to keep in mind with lists, and that's a really cool feature in lists. Okay, let's go to list operations now. So we can use concatenation. So if you aren't familiar with concatenation, like in strings, the same concept, you can join lists with other lists. So how does that work basically? So I have list sample, and I have another list, say sample 2, let's say that 4 and 9. I can join these two. So I say sample 3 is equal to sample plus sample 2, then say print sample 3. I print that, we get these two concatenated. I can also add another list to this. Let's say hi by, and we get hi by also. So remember, like in string, you can only concatenate list with list. You cannot concatenate lists with any other data type. So let's say I tried with 5, it'll give me an error. You can only concatenate list, not int, to list. That's how you concatenate lists. The next operation we have is repetition, and I won't spend too much time on this, so it's a pretty simple thing. So if I say print sample 2 times 2, so at 4949. So we took 49 and repeated twice and made a list from that. So repetition basically what it does is it multiplies, it basically repeats the elements as many times as the list is multiplied by, and creates a new list from that. So if I make it 5, I'll get 49 repeated 5 times. You can see here. Okay, the next thing is membership. So membership is used to check whether an element is present or not present in the list. So let me say I want to check whether hi is present in sample. Hi in sample, and it's true because hi is in sample. Let's say I want to check if by is in sample. It's not in sample, so false. Now if I add a not front, I'm checking whether by is not in the sample list. So it should return true because by is not in the list. And let's say I want to see hi not in list. I'm checking whether hi is not in sample, but hi is in sample, so it will return false because hi is in sample. While we're checking for whether hi is not in sample, false. Okay, next let's move on to traversing a list. So traversing basically means accessing the character of the list. And in Python, one thing we can do is we can use a for loop to access each element in the list. So what I'm doing is I'm create a quick for loop for element lm in sample print lm. What it's going to do is, you probably know what a for loop is. In every iteration, we have a new value for the variable here. So for in this list, what it's going to do is going to take for every element in the sample list, print that element. So in the first iteration, it'll print 3, then 4, then 5, then high, then none, then true. So every time this loop repeats, the value of lm changes to that basically the position of the element in the list, which corresponds to the number of iteration. This is what lm is. In the first iteration is 3, second iteration is 4, third iteration it's 5, fourth iteration is high, then none, then true. That's how this works. And when you run this, we get all the elements in the list. Now we can also use a slice here. Let's say I want to get only the first 3 elements. So say 0 to 2, 0 to 3. So we want 0, 1, and 2 elements, and we exclude the third element as I explained before. We get 3, 4, 5. So that's how you can use a for loop to traverse a list. Another thing you can use with for loop is you can use the len function. So I'm going to delete this quickly. Let's say for index in len range, len sample, you already know what the range function does, and we know what the len function does. Len will calculate the length of the sample list, and that's 0, 1, 2, 3, 4, 5, 6. So 6, and range 6 will create a list of all the indices from 0 to 6. So 0, 0, 1, 2, 3, 4, 5. It will exclude 6. Let's start with that. So for index in range 6, basically it'll go from 0, 1, 2, 3, 4, 5, those indices, and we can use those to access the characters of the element of the list. The sample index print that. We get 3, 4, 5 high and true. Okay, that's how it's done. So just to recap, every iteration we get the value. For every iteration we get each value in this list, and in range we get each index changes for each iteration. So we go from 0, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, sorry. And if we use for element in sample, it goes from 3, 4, 5 high, then true. So basically each element, each iteration means a new element. Now let's look at the same thing traversing using a while loop. So we go index 0, let's say while index less than length of sample, print sample index, and then index plus 1. Let's quickly break down this code. Here we're using indices to access each element of the list and print that out. So while the index value is less than the length of the sample, we're going to print the element at that index, and then increment the index by 1. So you make sure you always use an incrementer, otherwise it will be an infinite loop, and that will just, last time I tried doing that, it just made the program crash and I had to restart my IDE. So just don't do that. So print sample index. What I'm going to do here is print that. I'm going to run that. So we have 3, 4, 5, high, 9, true, same thing. So in the first iteration, we start with 0. So sample 0 is 3, printed that here. Then 4, then 5, then 5, then 9, true. So when we reach index 5, it's less than the length. So the length is 6. So right here, after this iteration, this loop stops, right? And then we got all these elements. So that's how you can traverse a list using a while loop. Now let's quickly look at the different built-in functions and methods we have for lists. So the Python parent library offers us a lot of functions. So what I'm going to do here is I'm going to show you each one of them quickly, how they work. So just do everything here. The first is len. We just looked at that. Length of the list. I think I'm going to skip that since it's not really needed right now. The next is list. The list function basically creates an empty list if no argument is passed. So if I say print list and you get an empty list, this is brackets, that's an empty list. Now if I pass a sequence, let's say pass A, B, C, D, E, and create a list with each element of that sequence. Now that's how you can create that, and that's how you can do that basically. And if I make it 3, 4, 3, 4, 5, get 3, 4, 5. So each element in each character in that string becomes an element in the list. Okay, next let's look at append. So append is basically concatenation, nothing new. So if let's say I have a list 1 is equal to 3, 4, 5, and I want to add value 6 to the list, I can either use concatenation, basically list 1 plus equal to 6, or I can just use append. And the thing with append is you don't have to add these square brackets, makes it much more useful. So I say append 6, then I print list 1. Let me change that here so there's no error. Let me get 3, 4, 5, 6. I can do the same thing I said before. I can go plus equal to 6 and I should get the same result. Yes, I did. So append is basically just concatenate the list, but it's much simpler thing. Now the thing with append is if you add a list to append, let's say list 1 dot append 5, 6, 7, it's going to add 5, 6, 7, that list, as an element of list 1, if you can see here. So let's say I just want to add each individual element to that the original list. So I use extend here, right? Extend, and we get each element added to the list. But if I use append, it'll add that list as an element. But if I use extend, it adds every item in the list as an element. That's a difference. That's a easy question to answer. What's the difference between append and extend? Append appends a single element to the list, but extend appends each element of a list passed as an argument. So you have to pass a list as an argument to use extend. So for example, if I use this, int is not iterable, so it has to be an iterable object. So adds 5, it'll add 5. 5, 6, it'll add 5, 6. These have to be iterable object. It can be list, it can be a string, anything that's iterable, which basically means you can use a for loop in it. That's where I like to remember what's iterable. You can use a for loop in it to traverse it. Okay, we'll move on to how to use insert. So insert is another inbuilt method. So it inserts element, basically the data type you want at a given index. So let's say I want to insert the value 5 at the 0th index basically. So I go 0, 5, and we get 5 at the first index. So what it does is on the left, the first argument, so we studied arguments in functions. The first argument will be your index number, and the second argument will be the value you want to insert. So I can also insert a list. For example, I want 6, 7, 8, and we inserted 6, 7, 8 right here. That's a use insert. Let's say there's a scenario when you want to count the number of times an element appears in a list. So let's say we have 5, 5, 5, 2, 2, 2, 2, 2, 2, 2, 3, 4, 3, 4, right? Let's say I want to count how many 3s are there in the list. Well, we can use the count function. Say list 1, I'll print that out, right? So list1 dot count 3. It's a 3 because we have 3 times. So we have the first occurrence over here, then over here, and over here. Let's say I want to see how many times 5 first should be 4. Yep. And if I want to see how many times 4 is in this list, oops, we get 3. So we have 1 here, 1 here, and 1 here. That's how you use count. Next is index. So the index returns the index of the first occurrence of an element in the list. Let's say I want to see where's the first position where 5 occurs. So we'll go index 5 and the second index, right? So we have 0, 1, and 2. So that's where the first position, first occurrence of 5 is there, right? And let's say the element is not present. It gives us a value error. So let's say I use 7, it says value error because 7 is not present in the list. Okay, next let's use remove. So remove basically can be used to remove a specific element from the list. So how do we use remove? So the first thing you have to know is that if you have the element present multiple times, it will remove the first occurrence from the left hand side the list. So if I say remove, if I want to remove 5, I can only remove the first occurrence from the list. I can only remove 3, 4, then 5 from that list. So I'll be left with 3 5s. If I want to remove all of them, I can iterate until all of them are gone. So let's say I want to remove 5. Dot remove 5. Oh wait, print that. We can't print this. Then return anything, just modify the list. I'm gonna say print list 1, and you can see the first 5 is removed. Now if I repeat this 4 times, say 1 2 3 4, you can see we got all the files moved. We can use a list for this option. We can use a loop for this obviously, but let's not do that for now. And also again, right here, if I want to remove something that is not present, let's say I remove 7, we get a value error since 7 is not present in the list. Okay, now let's move on to pop. And what pop does, it exactly just removes the last element of the list, or it can remove a parameter or the index. So let's say I want to, by default it's the parameter. Let's say list dot pop, it'll remove 4 from the end. Just 1 dot pop, sorry. Yeah, it'll remove 4 from the end. And if I want to remove a specific index, say I want to remove this one right here, the third index, say list dot pop 3, and it removes that index. So if you want to remove the element by the value of the element, you use remove, and if you want to remove a specific index, you use pop. Let's say it's index out of range 15, we'll get index out of pop, index out of range. It has to be in range of the indices in the list. Now you have a few functions left. Let's start with reverse. So if we use list1.reverse, we will get reverse. That what it'll do is it'll reverse the order of the elements in the list. So if you have 3 4 5 5 5 whatever here, you do this, it'll have the reverse from right to left. Right now it's going from left to right, now it'll go from right to left when you use reverse. And if you use reverse again, list1.reverse twice, you can see that we get the original list. Okay, now let's use sorted and sort. So sort basically just sorts the values in the list in ascending or descending order. So let's start with ascending. Say list dot sort, print list 1, so it goes ascending order. And if I want to print in descending order, we go reverse equal true, and we get descending order. So that's how you sort. So if you want to go ascending, you don't have to do anything, just say dot sort and then the brackets. But if you want to use descending order, you go reverse equal true as an argument. Next, we use sorted. So what you'll do is it's going to it takes a list and it creates a new list consisting of elements arranged in sorted order. So let's say I want to go list 2 is equal to sorted list 1, let's start as it list 1, and I say print list 2, and we get list 1 sorted. So you can also just use list 1 with sort, then list 1 equal to list 2, but this just reduces the length of the code, so you can create a new list using the sorted. And here we don't think we have the reverse. Now the last 3 ones we have are some arithmetic operations. The first is to find the minimum value. So let's say I want to find the minimum value in list 1. So right here we know it's going to be 2. Let's say I go print min of list 1, that'll be 2. That's the minimum value. And if I want to say print max, that's the maximum value, which is 5. So max and min, and then we have sum. Let's give the sum of every single element in the list. Now let's say I have string here. I haven't run it because you can't use the operation with integer string. So sum If you use sum, it'll only work with elements of the same data type. Let me just do again. So if I go 5, 6, I use sum, it's unsupported, right? Because you only use integers or floats for this. If I go again, let me try again. 5 and 5.5, 5.5, you're at 10.5. So only numeric data types can be used. We can't use strings in sum. But if we use, you can also not use min and max, because I think it's how the thing is, the code for this thing works. If I go 5 and I say min, sorry, let me repeat that at once. You can only use sum with integers, but you can use min and max and compare the ASCII values. So if I go min 9, we get 5, and if I say max, I get 9. But if I say sum, they will get unsupported operand types. So when using these three methods, remember that if you're using strings, it'll check the ASCII values, but you can't use sums. But if you're using, you can use integers for all three, number, data type, integers, and floats for all three of these, but you can only use min and max for the strings. With strings, you use that with ASCII value. So let's say, because the ASCII value of 5 is the 9, and let's say I go a and 9, and I want to print minimum, it'll be 9 because the ASCII value of 9 is the a. If I use capital A, I will get capital A because the ASCII value of a, capital A is less than lowercase a. It's a how to use these methods. Okay, now let's quickly look at nested lists. So nested list is basically a list within a list. So if I have list here, we have 3, 4, then we have 5 and 6. This is a nested list. 3, 4 is a nested list within list 1. So let's say I want to access a character within list, the nested list. So let's say I want to get 3 from this list. So I'll say print list, and we take the first list within this list. So the first element, 0, and we want the first value. So we use 0, and we add another thing here. So we have 0. Oops. What did I do wrong here? List 1. Yeah, list 1, and we get 3. So what here we did was, let me break this down. So list 1, 0th index give us this list, 3 and 4, and we want the 0th index of this list. So we use a 0 here as well. And if I want to get 4, I use 1. And let's say I add a few values to this, 5 and 6. And I want to get 5, I use 2. I can also use this to get 5. I can use 1 and 0. So what that does here is we take the second element in this list, list 1, and we get this first element from that list. So basically think of it, if you want to think of it this way, let's say we have this right here, we have a list of 4 and 5, and then we have a group 6 and 7 here. So let's say if I want to get 5, I'll have to first enter this whole area, and then within that area I have to enter this area and get 5. So that's how nested lists work. You use as many indices as you need, and if I can even add a third dimension in this. So I can say 3 and 4. If I want to get 4 from this, I can go 1, comma 0, list 0, where I take the second, so index 1, and then within that I take index 1, and we get a 4. So basically each layer, like each nested list is another dimension. So a 1D list would be this, a 2D list would be this, and then 3D list would be a list within this list. So basically that's how I like to think of it, as a different dimension. Basically you have dimension, shared dimension, dimension. You can go as many as you like. So it's pretty cool concept. Now let's look at copying lists. So we can also create a copy of list, because remember, we don't want to change the value of the original list. So if I say list 2 equal list 1, and I say list 2 basically change the relation, which is understand 1 2 3, and the list to 0, we change the value here to 5. Let's say print list 1, we get 5 to 3, because what it's doing here is not giving a copy of the list. When we say list 2 equal to list 1, it means that list 2 is now also referencing the same object as list 1. So Python is an object-oriented program language. Basically, everything is treated as object, and what it does is it maps variables, the identifiers, to the contents. So when we say list 2 is equal to list 1, basically the same mapping is there. So list 2 points to list 1, same value. So if you have list 1, list 2 separate, list 1 points to value x, and list 2 also points to the value x when we say list 2 to list 1. But we don't want that. Let's say we want to perform a different operation. We don't want to change the original list, right? Now we have to learn how to actually copy a list. So the first thing we can use is the copy method. The first thing we use is copy function. So we have to import copy. It's a module. So we say import copy, and list2 is equal to copy of list 1. And if I change the value list2, the first value, we're going to try that, is equal to 5. I print list 1, print list 1. You can see the value of list 1 is not changed because now we have a copy of list 1, and we can check that with IDs also. I won't do that for now, but what it's doing here is it creates a copy of the first list. So that means if I change the values in list 2, it won't affect list 1 since it's a copy, not the actual thing. You can think of it this way: if you have two sheets and they're identical but tier 1, it'll only affect the one that's torn, not the second one, the one that's the original. Okay, next we're going to use a method which is slicing. So basically, I didn't explain this when you were doing slicing before, but if you just use this, it'll basically slice the whole list. You'll just get the same list, but here you won't get the same, this new list won't put the same object, right? You'll only create a copy since you're basically copying apart the list to create a new list. So use this, and then say list2, first element equal 5 again, then print list 1 list. You can see only list 2 changed because it created a copy with slicing. So slicing is the second method we can use. Now I know in the textbook there might be a different order, but this is the order I remembered it in, so I'm just using that. You can go where the order you want. I'm just explaining what different methods we have to actually copy a list. So list 1, we use the slicing method to get everything in the copy. This is one cool feature of slicing. You can get everything using this. Okay, the next thing is we can use the list method, the list built-in function, basically. Sorry. So if I say list list 1, right? Then list of list 1, that'll give us a copy again. Another thing we can do. So here are the three main ways we can actually create a copy list, and copies of lists become very handy because sometimes you want to compare lists, you want to change values of lists without affecting the original list. So this is how you can use different methods of creating a copy of a list, which will help you sometime. Personally, I feel the easiest method of creating a copy is slicing because it's the least amount of work to do. You don't have to call a function, you just have to slice. That's pretty easy. And now one big thing I'm going to look at is how you can create empty list. So again, the two methods are create list 1 is equal to this, list 2 is equal to list. This is how you can create an empty list. Another thing you can, it's pretty much how you can create it. These are my favorite ways to create an empty list. There are probably other ways, none of them come to mind as of now, but these are two ways you can create empty lists. Next, let's go to functions. So in functions, we can use this as parameters. Now remember, we just talked about why we need copying. Well, functions, sometimes you might not want to, modify the original list. You might just want to use a copy with this to process whatever you want to do. So let's start with an example, so I can, better explain what I'm trying to say. So let's say we have a function def sample function func, and we want a list as a parameter. So say list one, and let's say list one plus equal to 4, and return list one. I'm gonna return this one. Okay. And now let's say list x is equal to 8, 9, 10, 0. Probably, yeah. Okay. List x is equal to this, and let's say I want to call that function and print that value. Print sample of list x, and get that basically. Now let's say I don't want to change the original value of list x, right? I just want list one. So what I'm going to do is I'm going to create a copy. So I can say list one equal to list of list one. Sorry, something wrong here. Yeah, I forgot to add that. And I say list one plus equal to 4, and we get the same output. Oops, list one. There. Yeah, the same output. But it might look the same, but let me just show you what is going on under the hood. So let me remove this for now. So let's say I want to print list x after that. You see the value of list x changed because when we use it as a parameter, we use it as an argument, then what it does, it modifies the contents of the object it's pointing towards. Let me explain that. It sounds a bit complicated, but basically when you're pointing towards an object, the list x is referring to 8, 9, 10, that list. And when I use that as an argument, then that function uses 8, 9, 10, 8, 9, 0, original object as the value, as the what it's operating on. But if I don't want to actually change the original value, I have to create a copy so that the original contents are not affected. So let me show you how you can do that again. So I say list one is equal to list of list one. Basically, I create a copy. Now when I print this, we get 890 because now we're using a copy. So only the copy. Now list one is referring to a new place in the storage. It's referring to a new location in storage, which has the same contents but not the same location in storage. So it's a bit complicated to understand, I guess, but once you practice a few times, you'll understand how exactly it works. So let me explain one more time. A list x points towards, when I use list x, I point towards the value in the storage 8, 9, 10 within square brackets. That's 890. That's what list x points to. And when I pass that an argument in the list without creating a copy, let me say this doesn't exist, then what it does is, what it'll do is then list one here, over here you can see list one now also points towards 890. So when we say list one plus equal to 4, then list x also gets modified because both list x and list one are pointing towards 890. So when we modify this thing in the storage, both of these will get modified because they both point towards 890. That's how this works basically. So that's why sometimes when using list as an argument, you want to create a copy so that the original list is not modified, but sometimes it also comes in handy if you just want to modify the original list itself. So let's say I want to purposely perform sample func. In this case I might not want to, but let's say in a hypothetical situation, I want to actually change the original value of list x. So I can just use sample func. But if I don't want to actually change the original value, I might want to keep it there for some other use. I don't know what right now. But let's say I don't want to change it, then I'll create a copy so that the original value is not changed. I create a new location in the storage. So the new location, what it does is it has the same value as list x, but at the same time, it's not the same location. So list x points to one copy of that, and list one points to a different copy of that. If you get what I'm saying, like with the paper example, list X is one paper, uh, list one is another sheet of paper. So let's pretend I tore list one, and list X is not affected because they're the same sheet of paper, but their copies are not exact same, right? Because technically they're the same, the blank sheet of paper, they're the same value, but they aren't the exact same thing. They're two different objects. That's how you can understand how this works. So let's move on to list manipulation. So there are different things in list manipulation that are there in the textbook, but here what they do is they basically just implement the methods and functions we just looked at. So I'm going to look at a few of these examples. We don't need to cover all of them. You can do those on your own. They aren't very hard, so I'm going to really look at them. The first thing in the textbook says, write a menu-driven program to create various operations. There's this. So basically creating a menu, you select a number and you perform an operation on that, right? So it's a pretty lengthy thing. So I think what we do is we can go through a walkthrough of that just to see how it works. So I'm going to quickly let me see what conditions we need. So what we do here is going to create a conditional construct and basically use a lot of if-else, if-elif statements to create basically a structure in which we can check whether we want to use which one. Let me see. That's a bit complicated to understand. Let me quickly explain. Okay, so we want to append list to given list, modify existing element, delete an existing element from position, delete existing element from the given value, sort the list in ascending order, sort the list in descending order, and display the list. So we have everything we need. We know all the methods we need. So let's just quickly go ahead and do that. So I'm going to start by creating the menu. Let me delete this. I'm going to create the menu now. So the first, let me print enter the, what do I say? Enter the value of the operation you want to perform. Okay. Next, I'm going to another print statement. And here I'm going to do some cool tricks so that we don't have to, spend a lot of time. So first thing I'm going to do is I'm going to use different things. I'm going to say step is equal to \n for a new line. So instead of actually, writing new print statements for each one, I can just do this, make it much faster. So start with the first one is append element to list. Then second will be insert an element at a given position. Third is append a list to the list. I'm doing something to reformat this like this. That's easier to read actually. You can do this, we'll treat it the same. It's a cool trick. Then after that, I'm going to say modify an element. Then, so next one is delete by position, comma, delete by value. After that, we have sort in ascending, then sort in descending, and display list, and then finally we want exit. So last is exit program. Let me just quickly add numbers to this. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now we're gonna do is let's see how this looks. Whoops, what did I do wrong here? Not a comma. Okay, now you can see we got all these. It's a cool trick you can use. It'll make your program easy to write and clean. Okay, next we're going to use choice. So first thing is let me use a while loop. While true, that it'll run infinitely until we tell it to exit. Indent that. Let me create a sample list. My list is equal to 4, 5, 6, 7, 8, and yeah. Okay, but we initialize a choice variable, choice equal to 0. Now I'm gonna do is I'm gonna ask for an input. So choice is equal to int input, enter the value. Okay, and that's a choice. And now we're going to create our construct. Let's start with one, append the element. So here we have, start here, if choice equal to 1, element equal to int input, enter the element, and then we should return that list, right? Elif choice equal to 2 here, it wants to insert a given position. So element, oops, here position equal to int, but enter the position. Then we're going to write my list dot insert dot insert position comma 3, new is equal to say list. It's a bit tricky one. So what I can do here is, let's say we want to keep the split, right? So I can just enter elements list, enter elements commas input. Here's quickly just move that actually be effective, and then dots split. Let's create a list, and then I'll say mylist.extend new. Right. Now there are many more options in this menu thing that they've given us. I'm gonna do three because it's gonna take a little time to actually write everything. Let me quickly run this to show how it works. So I want to start with 1. Enter the element, let's say 5. I forgot I should be printing the element at the end. Just print my list. I should probably print that so that it helps me. And is equal to /n. Escape, retry. Okay, start 1, 5. 5. I can see here we added 5. Next thing is insert as a position. So let's say I want to use 2. Enter the element. Let's say I want to enter 6 and 7. Oh, whoops, I have to enter integers. Should do that. 2, enter the element 6. I'm going to say I want to enter it at the first position. So let me say 0th index. So 0 index, and we get our thing here 6, 10, right? And third choice, new group end per element similar to commas. So let me add 4, 5, 6, 7, and you can see we got 4, 5, 6, 7. Oops, something. Oh, I forgot to separate by commas. Let me retry that once. Uh, 3, 4, 5, 6, 7, and you can see we added 4.7 using the split function. So that's how you can do it. I didn't add the 10th thing to escape, but you get the idea. We have to do. We take a choice, make a menu, and then just use the list functions we have, list methods and functions we have to, manipulate lists, perform operation, and all that stuff. So these questions aren't that difficult if you understand the concept. You can use all these really cool methods and all. So that's pretty much it for this video. If you have questions, you can obviously write them in the comments. You can also contact us via Instagram. Do follow our Instagram at qprogramming. You can DM us with any questions you have or any advice you want. So that's it for the video. Thank you for watching. Do leave a like and subscribe to the channel. It'll help if you really support us. We want to grow our channel. We want our content to reach more students. It'll really help everyone. Thank you.